Hi guys, Joe here. This is the first video of our differentiation video series. And in this series, we're going to be looking at everything to do with differentiation, be it the product rule, chain rule, differentiating different trig terms, and looking at how to apply them and when to use stationary points and etc. etc. First video we're going to be looking at is the differentiation from first principles. So first things first, what we know about differentiation is that when we differentiate a function, we actually get the gradient. This is what we learned in AS maths, right? So differentiating just gets us the gradient. So I'm going to call this function, even though this is a y is x graph, I'm going to call this y is f of x. So how do we get the gradient? Normally it's just change in y over change in x, right? So let's call this x value here, and this y value, I'm going to call it as f of x. This is a function, isn't it? Now, because we need two different coordinates, I'm going to go a further step ahead. I'm going to call this x plus h, i.e. the gap is going to be h. We're going to increase it by h. And so therefore, if I plug x plus h into here, then I get f of x plus h, like so. And so as we said, the gradient, m, or differentiating it, is just change in y over change in x. And in our case, the change in y is f of x plus h minus f of x over x plus h minus x, right? Which reduces to f of x plus h minus f of x over h, like this. Now, as you can see, the gap h is quite big, right? So what we want to do is differentiate. In differentiation, we differentiate a single point. So we can say that what happens when h goes smaller and smaller and smaller, i.e. it gets to 0. In that case, we introduce something called limits. And we say, what are the limits as h tends to 0, i.e. gets very small, of what we just worked out. So f of x plus h minus f of x over h. And what we've just derived is differentiating from first principles. So any function we can plug into here, and therefore we can get the derivative of that function. Right, let's show this with, let's say we'll use the function f of x is cos x. Okay, so using this equation here, I say limits as h tends to 0. F of x plus h just means plugging x plus h in the x position. So it's going to be cos x plus h minus cos x over h. What we can do now is we have this cos x plus h, right? And we learned in trig that we can use the compound angle formula to expand it. So this I can say is cos x cos h minus sine x sine h. If you guys have forgotten about this one, maybe go back to a different video and try and refresh your mind. And we have minus cos x over h, like so. Now, what I'm going to do now is I want to group together the cos terms and the sine terms. So as you can see, I have a cos x here, and I have a cos x here, so I can group them together. So I'm going to say limit as h tends to 0, cos x, open bracket, and we have cos h minus 1, minus sine x sine h over h. Okay, so now we've got the setup. What we have to think about is what happens as h tends to 0. So this only affects the h term, so it doesn't really affect the cos term, x term, sorry. So that means we have to look at what happens when cos h minus 1 over h. What happens when h tends to 0? Well, cos h is, well, cos 0 will be 1, so 1 minus 1 is 0. So this actually tends to 0 as well. If we look at sine h over h, it'll become 0 over 0. And in limits term, this tends to 1. Meaning that this term will disappear, leaving just this term here, where sine h is 1, right? And so what we are left with is that as h tends to 0, we're left with minus sine x, which incidentally becomes the derivative of cos x. Okay, so that's how we differentiate functions or show from first principles the derivative of functions. In A-level maths, you need to learn how to do the cos x one, the sin x one, and the tan x one. So maybe give those other two a try and then leave your answers or your comments in the section below.